All right, so we're going to talk about describing pairs of angles and some different information here. So complementary angles, supplementary angles, adjacent, and linear pair. So complementary angles, I'm just going to put a big C for complementary and a big S for supplementary. And usually you've heard these terms before, and sometimes it's kind of hard to remember. You know, one adds up to 90 and one adds up to 180. Well, my buddy Mr. Vogel, he likes to say complementaries add up to 90, supplementaries add up to 180, just using that one line there to help you out. Complementary makes a 9, whereas supplementary makes an 8. Okay, if you add that one line in there. So just kind of an easy way to help you remember if that helps out there. Complementary, add up to 90 degrees. Supplementary, add up to 180 degrees. A lot of times what you'll see are supplementary angles making a linear pair. They form a straight line, and the two angles together are two angles that add up to 180 degrees if you look at them, say, like that. Okay, so maybe like this one would be 60 degrees. This one would be, say, 120 degrees. And they don't necessarily have to be attached like that, but a lot of times you see them like that, and same thing with right angles. You'll maybe have that right angle marking there. So with the complementary angles, maybe you have a angle going through here like this, and maybe this is 40 degrees, and say this is 50 degrees up here. Okay, so those would be complementary angles, and I guess when I say those, I should actually say like A, B, C, and D. You'd say complementary angles, angle ABC, and angle CBD. I didn't want to spend tons of time on those in there because I do have a picture down here that may help out. So I have A, B, C, and CBD. Okay, and looking at those angles, there's your 50, okay, using your ABC, and here's your 40 using your CBD. So these two angles, since they add up to 90, make complementary angles, or they form complementary angles. Another way to look at it, though, you could have two separate angles. So maybe we call this one angle X, Y, and Z, and I'll call this one a 30-degree angle. And maybe angle, that one's really, I don't have to be perfect on my angles, but I kind of want to make them look sort of the right measure. Okay, didn't get too much better there, but maybe Q, R, and S, and let's call this one 60 degrees. Okay, so X, Y, Z and Q, R, S are complementary because they both add up to 90. They don't have to be attached. They don't have to have what's called an adjacent angle. They don't have, they don't have to be adjacent angles. Say if you have our right angles, or any angle for that matter, and they share a vertice and then this common leg in between. So ABC and CBD, those are adjacent angles as well. Okay, ABC and CBD, because they share this part. It's kind of like neighboring angles if you think of it that way. And we did talk about linear pair. That is a linear pair. Just remember, a pair means two. Okay. If I look at this diagram, I could also see some supplementary angles, or a linear pair of angles right here. So here's my straight line, ACE, and then when I take and look at this extra ray BC coming out of there, I could identify angle BCE, so this angle right here, and this angle right here, ACB. So those two angles that one right there, and this one right here, they're a linear pair and they're supplementary. All right? Well, the last thing that I want to talk to you about are vertical angles. And vertical angles work like this. If you have, say, a line and then another line intersecting it. So you have intersecting lines. Anytime you have intersecting lines, you get these angles across from each other. Okay? This angle, A, B, C, and this angle, D, B, E, they are vertical angles. And vertical angles are always congruent. So ABC are vertical. Another set of angles that would be vertical, ABD is vertical to CBE, which means they're congruent as well. You're going to see a lot vertical angles a lot this year. Okay, so if I look over at our diagram, we have some intersecting lines there. Since we have a 70-degree angle, the vertical angle to it is across from it. That's 70. And notice 70 plus this right here, 110 degrees, has to be 110 because it forms a straight line with it. They're a linear pair, and it's actually a linear pair this way as well, which means vertical is over here, which is also 110 degrees. It's kind of cool. You can figure different things out that way. All right. So one last thing, and then we'll move. You'll be done with this. Let's just say I'm not given actual measures. Let's say I'm given expressions for my angle. So if let's go ahead and call this A and B and C, of course, why wouldn't we? And we'll call this D here. So we know that angle ABC plus angle CBD equals 90 degrees because they're complementary angles. So the measure of those angles do. Okay, and so the measure of angle ABC we know is 2x plus 6. And the measure of angle CBD is 3x plus 4. And that is equal to 90 degrees. And so what I could do from here is, I could just solve for x. So I get 5x plus 10. Notice I just dropped the parentheses because they really don't do anything mathematically. They're just there to show we substituted in. Equals 90, which means 5x equals 80, which means x equals 16. Okay, and knowing that x is 16, if I actually want to find the angle measure of ABC, I can know that the measure of angle ABC is equal to 2 times 16, that's what x is, plus 6, or 32 plus 6, which is 38 degrees. And hopefully then, if I do the math, 38 plus what is 90? Well, 38 plus 42 is 90. Excuse me, not 42. 38 plus 52 is 90. So I'm hoping when I do the math, there shouldn't be tons of hoping, but that I get 52 degrees. So 3 times 16, also known as 48, and 48 plus 4 is 52 degrees. So yay, we did it right. Woohoo! All right. So ABC, 38 degrees. Measure of angle CBD is 52 degrees. All right. And now if we come over to the next one, we have just a linear pair. And in this one, we know that, let's label these. We'll call this one, no, let's not use ABC again. Let's use XYZ. And we'll label this one Q. Okay, so we know that the measure of angle XYZ plus the measure of angle ZYQ equals 180. And so going through the math here, XYZ is 4x minus 7. That's the expression there. Plus ZYQ is 8x minus 5 equals 180. And just, once again, dropping parentheses because they're not doing anything. We get 12x, negative 7, negative 5, minus 12 equals 180. Add 12 to both sides. 12x is equal to 192. And then 1x is equal to, 4, 4, 6, is equal to 16. All right. So we plug it in. 4 times 16 minus 7, or 64 minus 7, which is 50. 57. Whoops. Which is kind of funny since that does not look like a 57-degree angle. That's our obtuse angle. But that's okay. That's what I get when I just crank out some measures there. And 16 times our 8, so plugging in 16 here, minus 5 is equal to, well, 80 and 48 is 128 minus 5, which is 123. And 123 plus 57 is 180 degrees, so that's good. So even though it's a really bad label of diagrams, I probably should have switched these expressions around, but that's okay. We get the point here. XYZ plus ZYQ, we have 57 and 123 degrees. And if it makes you feel any better, to have a better picture, just switch expressions. You'll be good. All right, that's all we do.